whole lot more sense. Now we're going to go through the entire procedure. Step number one, we're going to read through the entire problem. Here's what it says. An office manager needs to purchase new filing cabinets. He knows that ACE cabinets cost $40 each. They require 6 square feet of floor space, and they hold 8 cubic feet of files. On the other hand, each Excello cabinet costs $80, requires 8 square feet of floor space, and hold 12 cubic feet. His budget permits him to spend no more than $560 on files, while the office has room for no more than 72 square feet of cabinets. The manager desires the greatest storage capacity within the limitations imposed by funds and space. How many of each type of cabinet should he buy? So the first thing you have to recognize in this problem is, what are we looking for? Well, what we want to find out is, how many ACE and how many Excello cabinets is this individual able to buy under these circumstances? So the first thing I'm going to do is, I'm going to come up with my representations. Now, if you're a chart person, this thing charts out very nicely. Do you have to do a chart? Absolutely not. But if you remember in the last, when we were doing chapter 6, one of the problems, or a couple of the problems there, we did charts, and I said they would be very helpful down the road. Well, this is down the road. Okay. We have ACE cabinets, we have Excello cabinets. We have no idea of how many of each type that this individual should buy, but that's what we're looking for. That's what we're looking for. Now, there are some limitations. There are some constraints. Can he just go out and buy as many cabinets as he wants to? No. Why not? Why can't he? Why can't you buy just anything you want to? Sure. Yeah, just in general, right? Do you have all the money in the world? You just go out and buy anything you want to? No. Do you have all the space in your house that if you went out and bought this stuff, you could put it in there? Probably not. So in this case here, he's under those same constraints. First of all, he only has so much money that he can spend, and he only has so much office space that he has. Those are the areas that we're going to deal with as far as constraints are concerned. So, one of the first constraints we have is cost. How much does each ACE cabinet cost? $40. How much does each Excello cabinet cost? $80. And how much money does he have to spend? $560. So there we go. We got that taken care of. Now the other thing we have to deal with is office space. How much office space does each ACE cabinet take up? How much office space does each ACE cabinet take up? 6 square feet. Okay, 6 square feet. What about each Excello cabinet? 8 square feet? It's going to be in square feet. Is it square feet?
Yes.
Okay, 8 square feet. And how much office space does he have? 72 square feet. Okay, you got 72 square feet. Okay. We go with ACE cabinet, 6 square feet? Okay, 6, 8, 72. Okay, we're in good shape. Okay, now, what is he trying to accomplish? Now, we know he wants to buy ACE cabinets or Excello cabinets, but what is he trying to accomplish? That is going to be, okay, that objective function that we're talking about, the objective of what he's trying to do. What does he want to do? Obviously, he wants to buy them. Why does he want to buy them? Why does he want to buy these cabinets? What's he trying to do? What's he trying to do? Yeah, he wants to maximize his storage capacity. Okay, he wants to maximize, right? Isn't that what it says? He wants to maximize his storage capacity. So, we want to maximize, and instead of calling it Z, we'll call it SC for storage capacity. How much storage capacity does each ACE cabinet have? This is going to be in cubic feet. How many cubic feet does each ACE cabinet hold? 8 cubic feet. And what about every Excello cabinet? 12. There we go. So far we have our objective function. He wants to maximize his storage capacity. For every ACE cabinet that he buys, he's going to get 8 cubic feet. For every Excello cabinet he buys, he's going to get 12 cubic feet. So there is our objective function. Subject to. These are the constraints that we were talking about last class. And in this case, our two constraints deal with our cost and our office space. Well, first of all, we have our cost. 40 times however many ACE cabinets that we have, plus 80 times however many Excello cabinets that we buy, has to be less than or equal to $560. That's all the money that he has. The other constraint we have is the space. For every ACE cabinet that he buys, he's taking up 6 square feet of space. For every Excello cabinet he buys, he's taking up 8 square feet of space, and he only has 72 square feet of office space in order to work with. Now, there's going to be 2 built-in constraints, and that's going to be in most of these problems. X is going to have to be greater than or equal to 0. Y is going to be greater than or equal to 0 because you can't buy a negative number of cabinets. You can't buy a negative number of anything. Does this problem now look like every problem we just did last class and every problem you did for homework? Exactly. Only now that X and Y stands for something. When we find our corner points, our X value is going to stand for how many ACE cabinets he can buy. Our Y value is going to stand for every Excello cabinet that he can buy. So we're going to proceed just like we did before. Now what we want to do is we want to graph these lines, and these lines are very, very easy to graph because is 560 divisible evenly by 40? Yes, it is. Is 560 divisible evenly by 80? Yes, it is. So we can just use our intercepts. Again, if you remember, when we did graphing, we graphed in 3 or 4 different ways. You want to pick the easiest way that you possibly can. If you're slope-intercept people, put those in a slope-intercept form and graph them that way, but I think there's a lot easier way. If I let X be equal to 0, Y is going to be equal to 560 divided by 8 gives me what? By 80 gives me 7. 1, 2, 3, 4, 5, 6, 7. There we go, here's 7. And if I divide 560 by 40, I get 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. That's right there. I'm going to go ahead and connect these 2 points as best I can here on the board. Again, you want to try to get graph paper and use a straight edge to do these because when you're doing a problem like this, they should all come out on whole numbers because you can't buy fractional portions of cabinets. So there's my first line. Now again, less than or equal to that means it would be down below here. Good? All right. Second constraint. Is 72 divisible evenly by 6? Yes, it is. 72 divided by 6 gives me what? 12, right? Gives me 12. 14, 13, there's 12. There's 12. 72 definitely divisible evenly by 8. 8 times 9 gives me 72. There's a 9 here. We're going to go ahead and connect these 2 points, again, as best we possibly can under the circumstances here on the board. Get that to here. And here. There we go. Now it also has to be below there, right? It has to be less than or equal to. So my feasible region is going to be everything that is below both of these particular lines. Okay, and again, we can go ahead and we can mark those lines. Okay, this line right here, 6x plus 8y is equal to 72. This line right here, 40x plus 80y is equal to 560. So there's my lines. There's my lines. Now the next thing we want to do is we want to identify our corner points. Well, in this case, they're very, very easy. They should all come out on whole numbers. That's why you want to use graph paper and a straight edge. Got one right here. That corner point is 0, 7. We have one here. We don't really care because we're not going to buy 0 cabinets, but that is a corner point. There is one that's right here, which is 12, 0. And then we have one which is right here. And once again, if you're using graph paper and a straight edge, that should come out right on one of those blocks. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. It even worked on the board, right on the money. That corner point right there is 8, 3. 8, 3. All right? Now, once again, when we were doing these before, we just had values for X, values for Y. They didn't mean anything. Here's what we have now. Out of all of the, remember, this feasible region contains every single combination of ACE cabinets, Excello cabinets you can buy under these circumstances. Does everybody understand that? That's important. Okay. However, out of all of these combinations, if he wants to maximize his storage capacity, it can only happen here, 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 or here. Now, we know it's not going to happen here, but it has to happen at one or more of the corner points. And yesterday we saw, or last class we saw, that it could happen at 2 corner points, right? We had a problem in which it happened at 2 corner points. Well, here's what this means. 0, 7, that means I can buy no ACE cabinets and 7 Excello cabinets. I got enough money. I've got enough space. I can buy 12 ACE cabinets and no Excello cabinets. I got enough money. I've got enough space. I can buy 8 ACE cabinets, 3 Excello cabinets. I've got enough money. I've got enough space. So that's great. You can buy any of those combinations you want to. However, we need a special set of those. We want the one that's going to give us our maximum storage capacity. How do we find that out? Very simply. We take our objective function. We have SC equals 8x plus 12y. We are going to go ahead and plug in our corner points of 0, 7, of 12, 0, and 8, 3. Again, do not need to plug in 0, 0. Well, 12 times 7 gives me what? 12 times 7, 84, right? 12 times 7, 84? Okay, so we've got 84, that's cubic feet. We get 84 cubic feet of files. If I plug in 12, 0, 8 times 12 gives me what? 96. I get 96 cubic feet of files. So that's good. If I plug in 83, however, I get how many? Okay, we've got 8 times 8 is 64. 3 times 12 is 36. 64 plus 36 gives me 100. I get 100 cubic feet of files. So once again, this individual could buy any combination of ACE and Excello cabinets that are in here. However, he wants to maximize his storage capacity. In order to do that, he has to do this, this, or this. In this particular case, what this individual wants to do is he wants to buy 8 ACE cabinets. He wants to buy 3 Excello cabinets. If he does, he will have 100 cubic feet of files. That is what gives us the maximum. There's our corner point, and there is our result. Before, when we were finding these corner points, they were just random X's and random Y's that didn't really mean anything. Okay? Now they do. Now they stand for something. And I think, like I said, after you do a problem like this, it begins to make more sense. Okay?